That's how good the Data Science Festival has been for me. I've done too much talking, but hopefully you can all understand what I'm saying a little bit. So I feel like this is the dream team. I feel like I've been watching Tamara all day, getting ready, and I've been really looking forward to it. So everybody, this is Tamara. She is Director of UA Data Science from Product Madness. Product Madness have been one of our partners for this year. They've been absolutely fantastic in supporting the festival. We've had great content in person and online, so massive thanks to Product Madness. Tamara, as you can see, is going to be talking about driving user growth with data science. We've obviously got some content first, and then Tamara will be taking any questions at the end. So I'll be looking forward to that. So if you're happy, Tamara,
yeah,
I'll get out of the way.
Thanks.
Okay, have a good session.
Hi, I'm Tamara. I feel really excited to be seeing people 3D rather than on Zoom squares. I'm feeling quite overwhelmed by that very same fact, so I may freeze halfway for the presentation. I hope you bear with me then. I'll promise I'll freeze. Okay, so as you may have gathered, I work for the company called Product Madness. Before joining it, I spent 7 years working for the Bank of England. For those who don't know, this is the central bank in this country. So I spent most of my time making forecasts for macroeconomic variables and thinking about behavior of households and corporates. Until one day, I heard the word data science. And I thought, I do data too. What do these people do? So after some research and a few interviews, I ended up here. And what I'm going to talk to you about today is really bringing the techniques that economists use to the world of data science, because this is the thing that I've learned. Actually, things that I knew were really relevant to the business context. Which brings me nicely to the plan for today. But before I go for that, I prepared this presentation with 3 groups of people in mind, and it would be nice to see who of you are in the audience. So I think one group that may find this interesting is essentially people like me 2 years ago, the ones who are interested in data science but not yet part of the industry. Are there any of you in the room? Okay, excellent, we've got one. The second group of people who I think may benefit from this presentation is anyone trying to optimize their marketing function, not necessarily even data scientists. So anyone from user acquisition? Oh, excellent. So a few of you, hopefully you'll learn something today. And I think the remaining group is, of course, the data scientists who may be working in other domains, but hopefully some of the techniques I'm going to talk about today will be relevant for you too. OK, so now I have a rough idea who's in the room. But yeah, any data scientists here? Yes, OK. So I can indulge myself a little bit and go for some equations then. So the plan for today, I'm going to do a quick introduction to how we make decisions about user acquisition at our company. Then I'm going to talk to you about something called scenario analysis. After that, I'm going to introduce a time series model and then show you an application of this model to optimal marketing mix. Before I jump into this, just a couple of words about the company. I think it gives good context for what I'm going to say afterwards. So Product Madness is a company that makes social casino games. Social here means people play with virtual coins. You win and lose virtual coins, not real money. We have users in over 150 countries, although we do focus on 2 key markets. And our marketing budget is over $100 million per year. That's why I guess we need the data science function to help and optimize that. In terms of the data that we have 2 main sources of data. One is generated by our users. These are the events that happen within the game. And we have about 1.6 billion daily events. I hope you're impressed by this number, by the way. And the second source of data we work with is collected for us by the third parties, putting together the data from our advertising partners. This is the data on installs. And we've got over 1 million of monthly installs. So again, some nice numbers to work with. So how do we make decisions in user acquisition? There is a budget per month. That needs to get allocated between the 4 apps that we have. Once that decision is made, for each app, the money needs to get allocated between different segments. And when I say segments, I mean different countries and different platforms, so Android, iOS, Amazon as well. Then, within each segment, we need to make a decision which channels or partners the money goes to. So that could be Google, Facebook, or more traditional TV, or maybe influencers, whatever else. And then, within each channel, there are different campaigns. So a campaign differ from one another by the audience you want to target, or by the creative you are using, or some other parameter. Okay? So this set of decisions, I actually don't even need to use the pointer. I've made it nice for myself. So this set of decisions is what I refer to as strategic decisions, right? Allocation between apps and segments. And these are the decisions made at the level of senior leadership team on a regular basis. This set of decisions, where you think about your advertising channels or partners, you can think of it as choosing the optimal marketing mix. And this is done by the user acquisition team when they do central planning. And the last set of decisions is done by individual user acquisition managers on daily basis. And so I refer to those decisions as operational. So today I'm mainly going to focus, let me try and use that. Yes, I'm going to focus on strategic decisions and how we make those. This is a way to think about it. I find this quite intuitive. So on your y-axis, you've got the money. On the x-axis, you've got the number of weeks since your new user installed. And you think of it not in terms of individual users, but a whole cohort of users who are installed, let's say, on 1 day or 1 week or the whole month. OK, your white line here is the money you're planning to spend in that month. The red line is the revenue you're expecting to build over the weeks. Where the 2 lines cross is something we refer to as payback window. So how much time does it take for the users to bring the revenue to pay for the cost of their acquisition? This is one of the key metrics that we use for decision making. But once you have these 2 curves, you can really calculate the ROAS metric, return on advertising spend. This is, for those of you who work on marketing optimization, you're very familiar with that. So you'll often be asked, what's your ROAS at 3 months, 6 months, 12 months? So this simple framework allows you to answer all these questions. The payback window, your ROAS at any point. So we know how much we're going to spend. We just need to do the red curve, right? Easy. So how do we do that? At this company, we tend to think about revenue as 2 components. So we call it on blended basis. So you've got the revenue from your paid users. And when I say paid users, I mean we pay our partners, like Google or Facebook, to show ads to people. Some of them see the ads, click install. This is the paid installs. The second component is the revenue from organic installs. Organic meaning people found us by themselves. So they may have gone on the App Store, browsed games, and found Heart of Vegas and installed. So we tend to think about revenue on the combined basis. Then you can further split each of those components into 2. So you can think of revenue as the number of installs multiplied by the revenue per install. OK? And we've got to the point where it's quite obvious what sort of models you need to build to think about these components. So how do you get to the number of paid installs? You know how much money you're going to spend, so you just need to know the cost per install, right? And you can think of that as a time series variable and predict that. The second component, you need a way to forecast the revenue per install, both for your organic and your paid users. And the third thing you need to do is to predict the number of organic installs. So these are the 3 components, and today I'm going to talk to you a little bit about 2 of those. So let's start with the revenue per install. Actually, in an earlier talk today by Deliveroo, someone's asked a really good question. Who's your user? if I'm ordering from the app and then my wife is ordering from the app, is it one user, is it two users? What happens when she orders from her own phone? So these are really important questions even before you start building out any curves. How do you define your new user? Is it a new device ID? Is it a new game ID? Is it a new advertising ID? This is something stakeholders never want to think about, but actually is important, and it's important to take time and talk to them about it. And the same question about reinstalls. How do you treat those? Do you want to actively track them? What do you do with the revenue when someone reinstalls? Do you still attribute their revenue to the original install, or do you attribute it to whatever brought them the second time? So these are some of the important questions to define. Once you define those, you can build a curve. So that's a typical curve. Again, on the x-axis, you've got the number of weeks since install. On the y-axis is the money. And here's a typical curve. So it's cumulative, right? So it's cumulative revenue. It keeps growing over time and then sort of flattens out. So Product Madness business model is based on in-app purchases, which is different to some of the gaming companies who mainly rely on ad monetization. And when you do ad monetization, what you care about is retention. Retention is a really stable metric, whereas average revenue per user is actually pretty volatile, and it makes it harder to build these curves. So this is a curve for 1 week for one cohort of installs. I've added some more curves here to give you an idea. So they're not, they have a similar shape, but it's not exactly the same. So it's an interesting problem modeling that, but that's probably a topic for another talk. I want to talk to you today about something else. So here are the curves. There is some uncertainty. You can build some confidence intervals, or you can show some interquartile ranges to your stakeholders when you tell them, like, what's the RPI going to be at month X? So instead of $10, you can sell them, well, between 8 and 12. But what do you do if that happens? No model is capable of capturing a change like this. And this is something economists have thought about before. So you can think about model uncertainty or risk as quantifiable risk. So your error term, your confidence bounds. And then there is this fundamental uncertainty about the world, about what may happen in the future. And that's a 19 uncertainty. And this is what's happened in 2020, I guess, to all of us. So some of you may have guessed what was the reason behind the divergent curves. So the sort of blue sets of curves were our normal pre-COVID curves. And by the way, this data is representative, but not relating to any particular app. And the red curve is the aggregate of this kind of violet curves on the previous slide. And you may imagine people during lockdown had a lot of time on their hands, so a lot of them started spending more time playing games and spending money there. So now we still need to make our monthly decisions, right, for the user acquisition. What do we do? Which curve do we use, right? And I believe this is not a question actually for the data scientists to answer, because this question is about your fundamental beliefs about the world going forward, and these are the questions about your risk appetite as a business. So what do we do? But how do we help our stakeholders as data scientists to make those decisions? We do something called scenario analysis. This is something, again, we did at the Bank of England ahead of things like Brexit, for example. We've used that at Product Madness. So you can think about COVID curves as your aggressive scenario. So if you believe next month your users will be bringing you so much revenue, you can go out and buy at very aggressive prices. At the other extreme, if you are very conservative, you can say, no, I think my users are going to be just like before, and this is the revenue they're going to bring. And there is, of course, always a way in the middle where you ask your stakeholders, so what do you think is the probability? What do you believe about the world going forward? What is the probability things are going to stay as they are now during COVID period? And let's say they say 70%, and then you say, okay. Then this is the curve that should, the dashed line here this is what you should be expecting. And this is the line you should be working with when you're making decisions. So the scenario analysis is quite a simple method, but we found it to be quite powerful when communicating with stakeholders and thinking about decisions. Whoa, okay, that was the wrong button. So let's move on to the next component now, the number of organic installs. So I've put, as a title of this slide, a pretty obvious thing. Forecasting the number of installs is a time series problem. Why did I do that? Well, again, thinking about my background, I thought, well, I'm going to go to the world of data science, and I'm going to work with predictions, i.e., you have 1 million of users, you know how they behave, you have the next user coming in, you need to infer something about that user. This is your prediction problem. But actually, what I realized, even in a company like this, with 1 terabyte of new data every day, some of the problems are inherently time series problems. And all that you have is literally one line going back. And so what do? Let's look at that line. Again, it's a representative line. So on the x-axis, you've got your time. On the y-axis, you've got the number of installs. One thing you may notice immediately here is that time series doesn't appear to be stationary. It clearly has a trend. And the trend for things like that may be affected by the change of the content in your game. It may be affected by the shift in competitive landscape or brand awareness. So you've got a story for why it's a non-stationary series. The second interesting and challenging thing is thinking about the impact of your paid traffic on organic traffic. Again, those of you who work in marketing will be familiar with the concepts of K-factor or attachment factor. And the idea behind is that as your number of paid installs keeps growing, that should boost your organic traffic too. And you can think of many mechanisms of why that would happen. So it could happen for word of mouth, maybe less relevant for this company. I guess for most mobile companies these days, the most relevant way is via app stores. So someone going in your app store and seeing you higher up the ranking charts, or you getting up higher in the search. And this is what your paid traffic helps to do. So I've put the blue line on the chart. That's the number of paid installs. Again, it's really hard to see a clear relationship between the two. Sometimes they seem to move together. Sometimes they don't. In technical terms, that means they're not co-integrated. So you can't just run a linear regression and say, here's my K-factor. No, you can't do that. So what do? Well, I'll show you what we've done. We use the structural time series approach that allows you to decompose the time series into different parts. So what I've done here is decompose the red line on the previous chart into the trend. And we were talking before, there's a good story for why there should be a trend in the series. The seasonal factor, this is something you would expect. That's in the green here. And then the red bit is the contribution from paid traffic. And as you can see, there was quite a bit of effect at the beginning of the series and seems to have been waning down kind of later on. And I think this is a really cool thing about this model. Instead of thinking about, oh, was there a structural break in my series? When was the structural break? You can actually just say, well, I think the relationship between the two series exists, and it evolves over time smoothly. It doesn't just jump suddenly at one period. OK, so I hope you're convinced this is a good approach. So now I'm going to show you how we actually did it. We've used a particular type of structural time series model, which is called stay space model. They're also known as Kalman filters. And believe it or not, they were originally used to track rockets in space. Then came Andrew Harvey and said, oh, no, it's a great approach. Why don't we use that for modeling socioeconomic series? And since then, people have been using that to model GDP and all other economic and social science variables, and we did it too. So how does that model work? It's composed of two equations, and I hope all the data scientists are really happy now. There are some equations on the slides. People from less technical background, excuse me for 2 minutes. So the observation equation, this is the one that tells you how your latent variable, or latent variables, that's a vector actually, that can be a vector, are related to the variables you observe. And in the case of rockets, what you observe is the data from sensors about the rocket's position in space. The second equation is called the transition equation, and it tells you how your latent variables evolve, so how at minus 1 becomes at. And in case of rockets, that's thinking about rocket moving from point A to point B. What do you need to know? You need to know its speed and acceleration, right? That's it. That's your latent variables. Easy. Now, not as easy, actually, when we think about the number of installs. Why? First thing is the noise term here. So when we measure rockets' position in space, we have a pretty good idea about the measurement error of our sensors. And this is, in other words, we have a really good prior, because this is a Bayesian approach. We have a really good prior on what the measurement error of the sensors is, and it's here. What does this term mean when you think about organic installs? Well, it's all the factors you really haven't captured in your model. And good luck thinking about those and having a strong prior on that. So in other words, you really have to make your data, you have to put more trust on your data, and your priors are driving the whole thing to a much smaller extent. And the second part, the transition equation, it's the same problem. Or we as humanity, we know how objects move in space. But organic traffic, we can have an idea. We can have an idea of how it works, but who knows, right? So it's to say it's genuinely a really difficult problem. Nonetheless, we try and tackle it. I promise this is the last slide that is just full of equations, but let me indulge myself and just talk you through that. So this is a particular implementation of the model you saw in the previous slide. This is how we think about the organic traffic. So YT here is the organic traffic, and it consists of 3 components. So mu t is a trend, and we say, okay, we think trend just moves as a random walk. Tau t is the seasonal component, and you can think about the seasonal component as a bunch of dummy variables that shoot it up to 0 with some noise. And that's the really cool part, right? You can see here the x is your number of paid installs, and beta here has a t coefficient, eh? Yes, so it evolves over time. We say it moves as a random walk as well. And that's what allows you this kind of relationship evolving over time, which we thought was relevant to the situation we had with the problem at hand. So now that you're familiar with the model, I'm going to show you how you can actually apply it to thinking about optimal marketing mix. As a company, we tried something new this summer. We tried running TV ads in 3 European countries. And this fall, we tried that in the US as well. It was very exciting. The hard part is the attribution, right? Again, for those of you who are not in the marketing domain, the way it usually works, you know the phone ID. You know the phone ID that saw the ad. You know the phone ID that installed the app. You bring them together and say, hey, this guy saw an ad from Facebook and he installed, so that came from Facebook. You can't quite do that with TV, right? Your phone is not attached to your TV. So how do you know how many installs the TV campaign brought to you? And here's another technique that economists use quite a lot. This is the idea of counterfactual. I like thinking about counterfactual as a parallel universe. Essentially, it answers the question of what would have happened had the intervention not occurred. And in this particular case, the intervention is your TV campaign. So here on the chart, you can see I've put for you an example of a series of organic installs. I can't quite see from here myself. Yeah. The white line is when the TV campaign started, and you can see the solid red line. This is how the installs evolve since TV. What is the dashed line? That's the counterfactual. So this is what your model does, right? Like you stop at the TV, at the point of the TV campaign start, and you say, what does my model forecast for the traffic going forward? And then you see something very different happening. And the difference between the two is your TV installs. Now, as some of you may know, the world of marketing has been moving to more data private world. And Apple introduced this big change to its framework this April, which means we're actually becoming less and less able to do that matching between who saw the ad and who installed the app. So this is the approach you can use going forward, not just for TV, really any type of marketing campaign. Now, of course, the further into the future you run, the more uncertain your model predictions become. So you can do that for a few weeks, but how about for a year? You wouldn't trust that too much, right? So you can do another thing. You can essentially introduce your TV variable, and again, that can be anything else, like influencers or any type of marketing campaign, directly into that equation that you saw before. So here is ZT is your TV variable. It can be TV spend, TV impressions, TRPs, whatever you want. Yeah, and then you get a chart like this. So instead of 3 components, it now has 4. And yeah, so this is the component the model attributes to your TV campaign. One of the tricks, now the question is, when can you start running this? Right? How long is long enough? How much data is enough? It really depends on the volatility of your series and the spend you're doing on TV, right? The same way in A/B testing. What's the noise of your series? What is the expected effect? It's the same question. But one thing that we found works really well in terms of the model being able to capture the effect faster is manually setting the change of the trend, so the error term in the random walk of the trend, to 0 for the first, let's say, 2, 3, 4 periods of your TV campaign. And then the model understands faster that, OK, this is coming not from the noise. This is not the trend changing. This is actually TV campaign doing something. I hope you like learning about TV, because I'm going to talk about it some more. So the cool thing about TV for data scientists is that the effects of TV can often be nonlinear. And there can be at least two sources of nonlinearity. And one of them, whoop, no, wrong button. One of them we refer to as carryover effect. The idea is the following. Situation 1, your ads are airing on TV just this week. Situation 2, your ads have been airing on TV for the past few weeks. And you'd think like maybe someone's seen it once is not going to install, but if someone's been seeing you on TV for the past few weeks, they're more likely to install. And this is the idea behind the carryover effect. And you'd think that would be true of any type of brand marketing, not performance marketing. Like the effect accumulates over time. This is why you do it. So how do you introduce that? So instead of adding TV variable into equation, you can add TV variable and the lags of the TV variable. And yeah, each of them will have a weight. But this is a lot of parameters for the model to estimate. So unless you have a lot of data, and in time series, let's be frank, you never have a lot of data. You want to make it simpler for the model. So one way to make it simpler for the model is to assume a geometric decay on the weights. And yeah, this is what we do. So then it's just one parameter. It's the decay parameter that you need to estimate. The second source of nonlinearity can come from what economists call non-constant returns to scale. Again, imagine you're running your TV campaigns only in a select number of channels, airing very infrequently. people are unlikely to remember you. Then you start scaling. So the same person is starting to see you 5 times. Maybe in time number 6, they see your ad they're actually going to install. And so the idea behind that is, as you scale, you become more efficient, right? You've got the increase in returns to scale. But at some point, you're going to hit a ceiling, right? Like, then when the person sees you for the 20th time, by that time, either they've installed your app already or thought, OK, maybe I'm not interested. And this is the second part of that curve. This is the decrease in returns to scale. And so there are actually two benefits to introducing that into the model. Benefit one, if this is how really the world works, your estimates are going to be more accurate. But actually, benefit two, you can also tell your stakeholders, oh, I think we're here. So actually, if we're going to scale our TV campaigns, we're going to be more efficient. Your CPI is going to fall. Or on the contrary, you can say, oh, you know what? I think we're spending here. So maybe we should consider spending a bit less and actually get more for our buck. I'll put up an equation here that I used to build this curve. This function is referred to as Hill function multiplied by beta coefficient. I won't bore you going through the parts of the equation. I've got the reference at the end that has all the details. We actually didn't come up with this nonlinearities story by ourselves. There is a paper on that, so I leave you to read the paper. So a couple of last words on here. One is on implementation. So how do we implement these models? For some of the models, we use BSTS package in R. That package was built by Steve Scott, who I think at the time was at Google. He has a nice blog article called Fit Invasion Structural Time Series with the BSTS package. It gives you a good introduction to the state space models and that package as well. It's less convenient for introducing the nonlinearities I was talking about. So to do that, we actually use Stan. That's another software. And Stefan, who is in the room, hello, Stefan. Maybe you want to show yourself? Yes. Stefan introduced the whole team to this software. It's really cool. So if you've got any questions on that, I'd encourage you to find Stefan after the talk. And I'll leave you some references here for Kalman filters, because obviously you're now all eager to learn more about those and go and implement them. Yeah, I think that's it for today, and happy to take your questions.
Amazing. Thank you very much, Tamara. Yeah, as Tamara has mentioned, we will take some questions. If anyone has any questions for Tamara, please show yourself now. I'm in big trouble here, aren't I? Like, what is going on? I'm going to have to kick something off then. Oh, we've got a question, sir. Please yell it out.
So you've spoken about acquisition, but what about engagement? Because you can have people who start down in the app, but after a while they might pay off and delete the install. So would engagement, continual engagement, be more relevant for revenue?
So engagement being relevant for the marketing campaigns, or? Oh, I see your question. So you're saying as you're scaling, you'd expect your revenue curves to change. Is that the question?
Yeah. I guess what I mean is, so you had that curve, say, once someone installs, there's a certain number of days in which you have that.
So let's maybe go to the curve. So is it this one?
No, early on.
This one?
Early on.
So RPI curves.
Yeah, RPI.
Okay. These ones.
Yeah,
So the very early one. Okay. Yeah.
Yeah. So it's not guaranteed that all the people you acquire before day 10 are going to continue using the app.
Yeah. It's a really good question, and that's why we model these curves at a cohort level, right? So there is strength in numbers, right? Like if you're looking at one person, you have no idea if they're going to be there tomorrow, right? If you're looking at 100, you probably know, okay, maybe 90 of them are going to stay, or let's say between 80 and 95. If you're looking at thousands and thousands, you know, okay, tomorrow like 92% sustain. I'm pretty confident. So, and it is a challenge for new games where you don't have really big cohorts, but as I mentioned, our games get about 1 million, well, actually over 1 million of installs per month, so your curves in that sense are like you can rely on them. Yes, some people will keep dropping out, but other people will stay and keep bringing you revenue. The good question is, again, like some of them will uninstall the app and come back. This reinstall question, do you keep attributing that revenue to here, or do you actually flatten that curve and start a new one? That's a really key one for the conclusions you make. Yeah, but yes, doing it at user level is really tricky.
Thank you for your question. Does anybody else have a question? There's another one here, please. We'll come to this side and then we'll come over to you next.
I was wondering if you try to vary the amount that you spend on paid advertising, only so that you can learn what's the effect of that on the organic acquisition.
So the idea of sort of doing something similar to A/B testing, right?
Yeah.
Great idea in principle. In practice, I think what we worry about is that the relationship between the two is not linear. So what you learn about your current level of advertising spend may be true within some bounds, and then once you move to another level, it may be quite different. Also, what you learn about one country may not be applicable to another. And let me explain maybe the logic a little bit behind that we had. When I talk to my colleagues in the user acquisition department, they tell me, in the US, when people look at the top charts in the App Store, they're really diligent. They go for about 20 apps. In Australia, if you're below 5, that's it. So, you know, if you've done that experiment in one country and then you want to transition your conclusions to another, that may not be relevant. And that's why we've come up with this approach where we sort of like tracking, okay, where is our attachment coefficient right now? And so does that mean we should try and increase the spend right now or decrease or stay where we are? So it's a little bit more dynamic, let's say. Yeah, thanks.
Thank you very much. There was a question this side, please.
Well, thanks a lot for this really cool presentation. I wanted to ask, this year with all the privacy changes that Apple has introduced, Google probably will follow, has this changed the way you use models like this one? Because I guess probably for you it's hard to attribute revenue at a user level or to keep attributing revenue for a certain cohort after 24 or 8.
Yes, that is a very good question and a very challenging problem. I'll give you a short answer, and then we can talk about it afterwards, because it is indeed a hard problem. I think the easy answer is you can use conversion value to split your blended revenue roughly into your paid and organic. Because if you, assuming you receive your conversion value properly, which not all of the partners are yet able to do, you can say people with conversion value 1. I know 20% of them came from organic traffic and 80% of them came from paid traffic. And then you look, because in your data, you can just calculate the conversion value yourself. So you look at the people, those you can track. You can track them as a cohort that had conversion value 1 going forward and allocate the revenue proportionally to your paid and organic, and do that with every level of conversion value. That would be one of the approaches, but it is definitely a really challenging question, and more thinking and models need to be applied. Yeah, thanks.
Perfect. Thank you very much, Tamara. I think that's us just getting to the end in terms of time. I just want to reiterate, Product Madness, you've been fantastic. Absolutely amazing partners. All of the content you've delivered has been amazing. So round of applause, please, for Tamara and
Thank
Product
you, David.
Madness. And as the guys mentioned, they will be staying around. So I would definitely recommend speaking to this lovely group of people and asking them lots of questions. So thank you all very much, and thank you, Tamara.
Thank you.